Hello, I'm Anna Mackay, and this video is on the distribution of sample means. So, suppose X is the result of a single spin of this spinner here. So X is the result, that means the different options that we could get. So we could get 1, 2 or 3 as our possible values. Now X2, so subscript 2 there, X bar 2 I should say, is the average score from 2 spins. So for example, if the 2 spins are 1 and 3, what would the average of those two be? You add them together and divide by how many were there, so you get 2. So X bar 2 would be 2. If the 2 spins are 2 and 3, what's the average of those two? Add them together, divide by how many is there, you would get X bar 2 is 2.5. So what possible values can X bar 2 take? So that's the averages from 2 spins of each different combination you could have. So imagining what they would be. Imagining what the average, so the mean of all of those outcomes could be. And just going back to X, what would the average be, the mean, of each of the possible values? So what would the mean of 1, 2 and 3 be? It would be 2. But X bar 2 is the average that you get from spinning 2 numbers. So comparing those two in your mind, what would you expect the mean of X bar 2? Would you expect it to be greater than, less than, or equal to the mean of X bar, which I've told you is 2? And what would you expect the standard deviation of X bar 2? Would it be greater than, less than, or equal to the standard deviation of X? So that means how spread out. Thinking how spread out the outcomes are. So you've got 1, 2 and 3. They're the spread with 2 as your mean. What about the spread of X bar 2, which is the mean of 2 spins? Try to think how spread out they would be. Is that going to be greater or less than? Moving on here. So suppose X is the result of a single spin. Calculate the mean and standard deviation of X. So here is our probability distribution, which is the distribution of all the probabilities. How do we work out the mean? Well, we take that and multiply by that, add on this, multiply by this, etc. But standard deviation, there is a formula, but this is what your calculators are for. So let's head across to that. So we had 1, 2 and 3, and the probability of each of them happening was 1 on 3. Again, a reminder that you need to set this, so hang on, calculate set, list 1 and 2 are showing there, and then calculate this. Our mean is 2 and our standard deviation is 0.816. So we'll just go back and write that. Mean of 2 and standard deviation of 0.816. Just pointing out that's also our expected value that we've done in the past. Okay, so that's X. What about X bar 2? So the average that you get from spinning the spinner twice and finding the average, so adding them together and dividing by 2. So as we worked out on the previous video, we have to take into account each of these. Feel free to pause the video or speed it up while I do this part. So what we have to take into account is if you spin the number 1 and then the number 1 again, what's the average of those two? Is another 1. If you spin a 1 and a 2, the average of those would be 1.5, etc. So here are our possible outcomes, and then to work out the probabilities of those happening, you have to take into account when each of those happen. So for example, the other way to get 1.5 is if you spin a 2 first and then a 1. Now in this case it's a uniform distribution of a third each time, so the probabilities are going to be the same if you go 1 then 2 or 2 then 1, but it's handy to know how this is worked out in case you get more complex ones that are not independent. So I'm going to write out my 5 scenarios. These are P's. What's the probability of X bar 2 each time? So equaling 1, 1.5, etc. X bar 2, so that's the X bar 2 is the average, the mean of 2 spins. So here are scenarios, and each of them happening is actually a third. So how could I get 1.5? I've got a third times by a third, because that's the chances of getting a 1 then a 2. And then this second one here is a 2 then a 1. As I said, feel free to speed this up, but I'm just going to be putting this here for future reference in case you ever need to come back and refer to it, how to work this out. And one more, and I think we're done. So then the chances of getting, the probability of getting a 2 could come from 2 and a 2, a 1 and a 3, and a 3 and a 1. And calculating these probabilities, you get a ninth and a ninth there, 2 ninths, and 3 ninths. So we have completed the probability distribution. But what about that mean and standard deviation of these? You'll need your calculators. So head on over to the calculator. So this time round we've got our possible values are 1, 1.5, 2, 2.5 and 3, and the chances of each of them happening are 1 on 9, 2 on 9, 3 on 9, 2 on 9 and 1 on 9. Work out our mean is 2 and our standard deviation this time is 0.577. So we'll write them down, that our mean, and sometimes we write that with a few subscripts here, our mean of x bar 2 was 2 and our standard deviation of x bar 2, so the standard deviation of rolling, of 2 spins, and the average of that is 0.577. How do these compare, the mean of x bar 2 and the mean of x? Well, you might notice that they're the same. So the mean of x bar 2 is equal to 2, and the mean of x is equal to 2 as well. I wonder if that's the case for all the time. So this was a sample size of 2 spins. What about 3 spins and working out the average? 4 spins? Yes, it is. And we'll come to that theorem in the next video. And so the theorem here is that the mean of, well, actually I could even rewrite that with an n, because that's our theorem, that regardless of the sample size, that it's going to equal what we call the population mean, so the original mean. And comparing the standard deviations, we had the standard deviation of x bar 2 was 0.577 versus the standard deviation of just x, which was 0.816. Now, they're not the same. So, how big or how small are they in comparison to each other? And will that connection be something that's uniform as the sample size increases? It is. To work out the connection between the two, divide them. So we have, I'm just going to call that one sigma. So sigma divided by sigma of x bar 2 gives you approximately 1.414. And if you're good with your trig, you will know that that's approximately root 2. So the square root of 2. What's significant about 2? Well, that's how many spins there were. That was our sample size. And so the theorem here is that the standard deviation of x bar n, of the sample size there, is equal to the standard deviation of the whole population, which is just the standard spin in this case, divided by the square root of the sample size. So summarising there, that if the random variable x has mean mu and standard deviation sigma, so that was just doing a spin and getting 1, 2 or 3, then the distribution of sample means x bar n has the same mean of mu, and this time around a smaller standard deviation of sigma divided by the square root n. So it means over time that the numbers will be less spread out as you take samples of them. And visually here, if we've got the same mu every time, the standard deviation is getting smaller as n increases. So that means in the case of this spinner, if you did 5, 10, 20 spins and took the average of all the scores that you get there, how spread out they are, and the possible outcomes that you can get are going to be less. And so that standard deviation is decreasing, and hence why if it's less spread out, it will be further away from the mean, but therefore the bell curve will be much higher. And this concept is called the central limit theorem, and that's coming up in the next video. Thank you.